Hi everyone. So my name is Deepa, and today I'm back with a lead code problem, and this is problem 202 happy number, which is the lead code easy. So let's get started with this problem. This problem is asking us to write an algorithm to determine if a number n is happy. Now, a happy number is defined by the following process. With starting with any positive integer, we need to replace by the sum of the square of its digits. Now we need to repeat the process until the number equals 1, or it loops endlessly in a cycle which does not include 1, and those numbers for which this process ends in 1 are happy. So we need to return true if n is happy and false if not. Now the 3 points that they've given for defining a happy number are extremely important and are guiding us to the solution. Let's go through the example. I've already commented it out so it becomes easier to understand. Um, so let's go through the first example and see if the number is happy or not. And for n equals to 19, the first loop, as we can see, is that we start with a positive integer and replace the number by the sum of the squares of its digits. So starting with a positive integer, 9 square is 81 plus 1 square is 82. It's still not equivalent to the sum 1. The second loop will go, and like it's saying in the definition, we repeat the process until the number equals 1. So 8 square is 64 plus 4 is 68, and it's still not an happy number. A third loop is 6 square plus 8 square, which is 64 plus 36, and it's equal to 100. Now finally our fourth loop is going to give a sum of 1 because it's 1 square plus 0 square plus 0 square, and hence this number is a happy number. Now the first example is simple, but let's look at the second example and really try seeing why 2 is not a happy number. So for n equals to 2, the first loop is equivalent to 2 square, which is equal to 4. The second loop will iterate and go through 4 square, which is equal to 16. Third loop will be 1 square plus 6 square because we're summing up the digits of our integer. So 1 square plus 6 square is 37. Our fourth loop is 3 square plus 7 square is 58. And our what we notice is that by the time we reach the fourth loop of 58, let me show what's exactly happening by the solution in lead code itself. So when we are looking at this 58, which is our fourth loop, when we recursively keep going through our loop, we revert finally into a cycle essentially, which will revert back to the original integer of 58. And we're gonna keep going through this cycle over and over again and actually never reach a sum of equal to 1. So in this example, after 58, our fifth which is our after a fourth loop of 58, we'll be reaching our fifth loop of 89, sixth loop of 145, seventh loop of 42, eighth loop of 20, ninth loop of 4, 10th loop of 16, 11th loop of 37, and reverting back again to the 12th loop of 58. When we do this, because we're looping again into 58, we've essentially reached a cycle, and it's going to happen over and over again, and we're actually never reaching a sum of 1, which means that 2 is actually not a happy number because we've gotten into a cycle. And this is exactly what the description is trying to show us, that it loops endlessly in a cycle which does not include 1. So this is not a happy number. And to understand how it is if one goes into a cycle, we'll be creating a hash set, because set only takes the unique occurrence of a number. If a number has been seen, if a total sum of digits has been seen before, and if it's seen again, the set will return a false, because sets can only take unique occurrences, and we'll return it as a not happy number. But there are other things in this problem, such that how do we find the individual digits and square them, and I'll be explaining through it once I write the code for this problem. So let's get started. So we define a set, as I said, a hash set. So a hash set is let's call it sets is equal to set, while nums, because we do not want our sum of our digits to be equal to 1, and set and nums, we do not want our nums to be in set, nums not in set. We do sets dot add nums, and do nums is equal to get next nums. We only return when nums is equal to 1. So because we only, the final output of our total sum of digits is equal to num, so this get next function should essentially return the sum of the digits. And I'm going to define that now. And this while loop is simple because we do not want our set to have we do not want our total sum of digits be equal to 1, and our we do not want to update our sets, or if nums has not been seen before in the set, because if it has been seen before in the set, we will return a false, because sets only takes a unique occurrence um, of a number. So let's go through this problem and see how will we define the get next function, which will take the um, define get next num. So uh, in our case, let's not call it num, sorry, let's actually, let me change this to nums. So let's call its total sum is equal to, initialize it as 0 because we want the total sum of our digits, and while nums is greater than 0 because they've said that um, start with a positive integer, right? So we need to make sure our digits are greater than 0, and what we now do is that we take our nums, our digit, and we do nums div mode, which is, I'll explain this now, how what does div mode do with that example. And then what we do is that we take the total sum and we do plus equal to digit the whole square, and we return total sum. That's it. We have taken the total sum of plus of equal to individual digits, and we're returning the final total sum. This is going to iterate through recursively until we reach a sum of equal to 1. Let's submit this and see. Great. So all the test cases have been passed, and I can now the example number 19 has also been accepted. So let me go through the problem and explain what exactly is happening through this code by actually just doing the first example number 19 in our case. So let's do number 19 here. So let's go to the first code one by one and explain you what is happening by just doing the first loop, and then I think the remaining loops will make sense when you write the code for this. So let's call a set here. So essentially what is happening is that in case of 19, right? So while nums is not equivalent to 1 and nums is not in set, so obviously 19 is not equivalent to 1 and 19 is not in set, and we will add 19. Now we add 19 sets dot add nums, and we define a new nums now which is equal to get next nums. But what is get next? And we've defined this function. So let's go through this nums. Let's go through this function and see what happens now. What is our new nums now? So essentially, because nums is greater than 0, nums comma digit is equal to div mode nums comma 10. So what div mode operator does is that it will divide and return the quotient and the remainder in a form of a tuple. So in our case, when we do div mode in nums is 19, right? So this will run as div mode 19 comma 10 for our first example. So this will actually return the quotient in our case is 1. Sorry, the quotient in our case is um, it will return a tuple in the form of um, yeah, quotient and remainder. So no, remainder and quotient, my bad. So in our case it will be 1 comma 9. Yeah, and then we can see now that um, we can see that the digit is 9 and our nums is 1. It's going to square the digit 9 square 81, and our total sum will become 81. But notice that we haven't, our nums is still greater than 0 because nums is 1. So it's going to do the div mode again, but now instead of um, 19, it's going to take div mode of 1 comma 10, which will be equivalent to 0 comma 1. So notice that it has actually taken the unique integers, and this is a very common trick when we're going to iterate through each integer in our sequence. So we always use the div mode operator function, and this is now the digit is 1. So we are doing 1 square now, and we're adding it to our total sum, which was now our total sum has become, in this case our total sum was now um, 81, and now it has become um, total sum is equal to 82 because we have added our 1 square, and then it's going to return total sum, which is equivalent to um, 82. So it's as simple as that. And then so now our nums will be equal to 82, right? But it's still not now this nums is not in set, so it's going to iterate through this. So basically now our set will have 82. 82 is again going to pass through this function, recursively update the total sum, which is 8 square plus 2 square, which will be now 64. And then by the time it reaches 100, so when it reaches 100, um, it will add this 100, but now it will notice that, well, okay, get next sum, our return nums is actually equal to 1. So that is when our code will stop and return a true. So I hope this problem was made sense, and everyone was able to understand the code. I will see you all next time with a new problem.